Good morning. Thank you very much. My name is Masaru Watabiki. I'm responsible for SQM business development. 今日はですね、皆さんお集まりいただき
Thank you very much, everybody, for gathering. My name is Watabiki. I am from Toshiba Digital Solutions Corporation. SysTech last week and Q2B this week. So you are in contact with the world of quantum. And quantum-inspired is what we have been focusing on, rather than the technology per se of quantum, but leveraging quantum and so solving issues of some sort in a quantum-inspired fashion. Therefore, in quantum-inspired multiplied by something, this empty box, you might fill it with your challenge or something that you want to realize. Just imagine what you want to see happen. So with that in mind, please listen to my talk. All right. So just to briefly introduce myself, I am from humanities. I am a humanities graduate, not science. Now, 2019 was the year where I entered into this world of quantum, and QKD, Q-Star. I have been involved in Q-Star, Quantum Strategic Industry Alliance for Revolution, and I have been involved in various committees and working groups. So from here on, I'd like to talk about our company and then some of the examples in the finance as well as drug discovery areas, among others. All right, so about Toshiba. For the sake of tomorrow, for humans and the world or the earth. And that's really what we're trying to realize. And therefore, carbon neutrality or circular economy is a must. We really have to realize them. At Toshiba, energy-related and social infrastructure-related businesses has been our arena, and we have been solving challenges. And in those years, we have accumulated data or the methods for acquiring data. These are what we have that we can leverage now in the world of digital transformation, DX. And then in 5 years or 10 years' time, we will have a QX world. Once quantum transformation is pursued and realized, then we want to fully leverage quantum technology so that we can develop a infrastructure or have an infrastructure that everybody can access and utilize. Okay, so let me talk about SQBM+, the quantum-inspired approach that we take. And there are some forecasts for the future as well, what we want to or will realize. Large-scale combinatorial optimization problem to resolve in a fast speed is what we are trying to do. We have Azure Marketplace and we have these already available, and you might already know this. Optimization problems includes congestion mitigation, logistic optimization, as well as financial portfolio optimization and molecular design for drug discovery. Now, in Toshiba, the quantum computers themselves have been an area of research, and this quantum bifurcation machine is the name that has been given. In the process of that research, we came to think that maybe something similar can be done in the conventional classic computers, and they found out this high-speed algorithm, which can speed up things quite a bit. And so in 2016, we made that announcement, and papers were written and posted. Now, Toshiba Digital Solution is the business entity, and we are implementing this technology in a software to be available for the customers. Actually, in April, we had a very good news. We were given this Ministry of Education, Science and Technology award in April for this fiscal year, for the researchers and the members that were involved in the commercialization of the technologies. You see the photo, and Mr. Goto is at the very center. who identified or found this algorithm to begin with. And the members that implemented this on the FPGA or in the cloud, these 5 members were subject to this award. And we would like to, of course, develop this further with this as a trigger. So as I said, we want something that can be useful immediately. So Marketplace, Azure Marketplace, and FPGA test marketing is done, and we're providing the service within that framework. And also for commercial or practical application, I would like to address that subject on the following slides. These are the major steps. So 10 million is what we're supporting, scale to 10 million. I think this is the way forward. That's the variable number. And to the qubit, we have Pubo. We will support Pubo as well as QPlib as well. In addition to Cubo quadratic unconstrained binary optimization. So Pubo, Cubo, and Plib as well, QPlib as well. And we can select various types of GPUs as well, as they are supported. And this is a list of the products that we offer. AWS Marketplace and Azure Marketplace are both shown. The partner version, as we call it, is for business use, where our partners or end users can leverage our service. At the end of last year, customers with data centers and also customers with sensitive data have difficulty using cloud, and therefore we issued or released this on-premise version at the end of last year. A100, H100 are covered here. Red Hat RPM is the operating system, which I'm sure many are familiar with. If you have certain needs in this area, I encourage you to consider the on-premise version of our product. Okay, regarding solvers, as I mentioned, we have Cubo, which is the quadratic unconstrained binary optimization, but we also have higher order being supported at Pubo, a solver that supports higher order terms and cubic and quartic problems, and QPlib, QPLIB, that actually solves quadratic binary programming problems with linear constraints. Now, customers, some of them want to use the service as SaaS. Therefore, SaaS model has been developed as a standard, and we released this domestically last year. But for overseas markets or global markets, that is, around the world, we wanted to make this available, and so we adopted this as a standard machine. And so even outside of Japan, if the service is something to be provided as a service, then this is available as well. From here on, let me talk about SQBM plus 10 million plus is what we are working on towards in terms of variables. And in autumn this year, we're going to release something that is more advanced. I cannot tell you exactly how big of a scale. However, I would say it's quite huge. And also all the innovations that went into this new upcoming product, I encourage you to look forward to our announcement in fall this year. Okay, from here on, I want to talk about some of the challenges. I wanted you to think about the challenges that you want to solve. And I would like to explain some of the use cases or examples that Toshiba has addressed so far, starting with finance.
Regarding finance, we do have a history. For example, this 2019, our research lab worked on this forex arbitrage trading, and then from that, Daruma Capital, which conducts the HST services. And actually, we had that company using our technology for the stocks. And actually, after a year, the result was satisfactory. And we were not happy with just being satisfactory, so we wanted to do more. We wanted to evolve this. And now we're using the AI to improve it further, which is shown at the top of the slide for system for HST. Now, at the bottom, using that HST technology, we are trying to implement it to the derivatives trading, for example. And in 2022, for the lab level, MIS portfolio strategy was worked on. And now, in US, startup, we're working with them to use their AI mechanism to improve this or evolve this further so that the model created using that system will make sure will provide the more profitable business. And also, we are getting some support from academia to working on the SIP program. Now, at the top of the right, you see the word AI. And this fall, we will be able to talk about some specific item regarding the use of AI in financial services. Now, this year in April, in spring, at the World Economic Forum, they have the Quantum Application Hub. And it says 13 here, but actually there are 14 use cases displayed there. And if you go to that portal, you see one of them is us. And then that talks about the forex trading, and we are the only Japanese companies who was selected in that use case showcase, and also we're the only one which uses the inspired quantum inspired technology. Now on the right side, on the left side, you see the example of the activity we're doing with the U.S. startup, and SQBM is used based on the result coming from the SQBM. So we are trying to grow the revenue here. And also on the right side, we are using a machine learning model. Here again, we are working with a venture company. And then after the result, which is narrowed down, the trading of the stock is being performed. And for both of these projects, we are targeting at the launch this autumn. So I've talked about financial services sector. Now I would like to talk about drug discovery. IT drug discovery is growing very rapidly, and then we anticipate the market size for the IT drug discovery will reach 4 to 8 million by 2030. And of course, we have to work with a partner who is really strong in that sector. And bioscience, for example, has a lot of drug discovery. And the other company mentioned here is Abbott Biocomputing. This is a spin-off from a university. And so we work with them, both of AI Bioscience and also Abbott Biocomputing, for the development for the drug discovery. And here we are focusing on what's called allosteric drug discovery. And then by using this methodology, we can expect to grow the pool of the drug discovery target protein by 3,000. And we're trying to find where is the lever to affect the diseases in the result. I mean the end of the allosteric site receives the input. And then we have applied for patent in 2022 for the methodology for predicting allosteric control. And so using AHEAD biocomputing and also Aoi Biosciences, we're trying to develop this drug discovery ecosystem. And we developed the Cubo site errors and then develop the prediction. And actually, there are paper which shows the experiment result, and then we are actually mapping our prediction versus the experimental data, and the comparison delivers us a very satisfactory result. Now, I would like to share with you one other example, which is we're working with ICE, and we actually delivered our on-premises version SQBM Plus to them, and they are preparing for the launch of the services coming weeks. So once this becomes alive, you'll be able to actually do research in the SQBM Plus environment. Now, there's some example of the use cases. This is the example of the groove notes, and then this is the shift scheduling or shift optimization calculation using AI for the staff who work in the plant, and they're actually using it. Another example, this is in the case we worked with Topan last year, and this is about the optimization of the warehouse, the picking route in the warehouse, and also the shelf allocations are also optimized at the same time. And here, this problem was not solved only by using SQBM Plus. So we combined that with the classic solver. Well, at the time we were using optimizer of Google, but it doesn't have to be that way. It can be other classic solver, but in any case, we integrated the class solver and SQBM Plus. And the solution of the hybrid is something that we have applied for a patent. It's pending. And now, in comparison with the solution that Topan is currently using, there's increment of like 15% in terms of efficiency in the time used for the picking route generation. Another example is our collaboration with JI Zept. And what we did there is the scheduling optimization for the EVs and also charging stations. It's the matching optimization between the vehicles and the stations, the charging stations. As the number of the vehicles goes up, there may be congestions before the stations. And because we can anticipate such a problem, we wanted to understand what the way to prompt EV vehicles to go to different stations at the right moment. There are different constraints in operations, and those constraints can be covered by the technology that GZEPT has, and SQBM Plus is used to do the fast matching after the covering of those constraints. And by combining the technology together, we achieved 20% reduction in waiting time of the starting and the charging stations. And we're now proposing this technology or solution to the municipalities. So quantum-inspired technologies are becoming the age where commercial use is possible. We would like to support you from the stage of the research investigation up to the implementations. We have exhibition booths out there, so please come to us. And this QR code brings you to our website, and there you'll be able to see the context, for example, if you're interested. So thank you very much once again for your precious time. We have two questions, so I would like to read those questions. So you said 10 million qubits. I believe this is the number of the physical qubit. Is that right? Yes, that is the number of the physical qubits. And also another question is written in English, so let me try to translate. So this is a solution focusing on large problems, and when that is done, inspired technology will treat that kind of development in the future once SBQ QB and plus is realized, FTQC is realized. Yes, there are some use cases that will absorb into FTQC. Maybe there's some difference in the use cases. We have to see. In case of FTG is used, that means the embedding will be possible. So for such use cases, I believe there will be division of the roles. Thank you. Once again, let us give a big applause to Watanuki-san. Thank you.